We're going to look at some quadratic simultaneous equations. So these questions would appear on the higher GCSE paper. We've got a question here that is 6 marks, and it says solve 5x subtract y equals 5 and 2y subtract x squared equals 11. Now this doesn't mean solve these separately, it means solve these equations when they are simultaneous, so they happen at the same time. So if we look at a graph that shows the graph of the linear equation at the top and the graph of the quadratic here, what we are trying to find are the points of intersection of those two graphs. So I'm going to insert a picture on GeoGebra showing a drawing of this linear equation and this quadratic equation, and you'll be able to see that there's actually 2 points of intersection that we're going to be finding. In order to start solving this, we're going to rearrange both of our equations so that we get it of the form y equals. So if we look, I'm going to call the linear equation equation 1 and the quadratic equation equation 2. We're going to start by rearranging 1 to get it of the form y equals. So we've got 5x subtract y equals 5. If I start by adding y to both sides so that we get a positive y on the right hand side, I get 5x equals 5 plus y. Now here I've got 5 plus y on the right hand side. I said before I just want it in terms of y. So I'm going to subtract 5 from both sides and I get y equals 5x subtract 5. For part 2, equation 2, I'm going to rearrange this so that I get, again, an equation in terms of y. So I've got 2y subtract x squared equals 11. I'm going to add x squared to both sides, and I get 2y equals 11 plus x squared. Now we could then divide everything by 2 to get y equals 11 over 2 plus x squared over 2, but I'm actually going to just leave it like this. At the end, if you want to go through this process again, but dividing this equation by 2, you will see that you can get the exact same solutions as I will. So we've got the equations y equals 5x subtract 5 and 2y equals 11 plus x squared. I'm now going to call these two equations, we've got equation 3 and equation 4. I'm going to substitute equation 3 into equation 4. Since we've got y equals 5x minus 5 and 2y equals something, we can just substitute this equation into that one. So I get 2 lots of y, which is 5x subtract 5, that's equation 3. That's equal to 11 plus x squared. So I've started with equation 4 and substituted y equals 5x minus 5 into that equation. I'm going to now expand this bracket. 2 times 5x, that's 10x. 2 times negative 5, that's negative 10. And that's equal to 11 plus x squared. So what I've done now, I have substituted in these equations and I've got a quadratic in terms of x. Now to solve a quadratic, remember we're finding those roots of the quadratic. So we're going to rearrange this quadratic so that it's equal to 0. So if I start by adding 10 to both sides, I get 10x is equal to 21 plus x squared. I'm now going to subtract 10x from each side, and I get 0 is equal to x squared subtract 10x plus 21. So that is the quadratic that I want to solve. Now I can solve this by factorising the right hand side into 2 brackets. To factorise, I'm looking at my factors of the number at the end of my quadratic, so the constant term. So I'm looking at my factors of 21 that make a sum of negative 10. So my factors of 21, of positive 21, that make a sum that's negative, they must both be negative. So I've got negative 1 and negative 21. They don't make a sum of negative 10. I've got negative 3 and negative 7. Negative 3 plus negative 7 is negative 10, so they're going to be my factors. So in my brackets, I'd have x subtract 7 and x subtract 3. So looking at the quadratic that we've just factorised, if this is equal to 0, then we know that one of these brackets must equal 0. Now if x minus 3 is equal to 0, then we must have x equals 3. If x minus 7 is equal to 0, then we must have x equals 7. What we've done here, we've found the 2 x coordinates of our 2 intersection points from the graph that I drew of our simultaneous equations. So I have found my x coordinates. All I need to do to find my y coordinates is to substitute an x value into one of my original equations of the simultaneous equations that were given. So I'm going to first of all substitute x equals 3 into equation 1. So we have 5 lots of 3 subtract y equals 5. 5 multiplied by 3 is 15. So we get 15 subtract y is equal to 5. I'm going to subtract 15 on both sides, and I get negative y is equal to negative 10. Can then divide by minus 1, and I get y is equal to 10. So when x equals 3, y equals 10. And that is our first solution. I'm now going to substitute x equals 7 into that first equation. So substitute x equals 7 into equation 1, and I get 5 lots of 7 subtract y equals 5. 5 lots of 7, that's 35. Subtract 35 from both sides, and I get negative y equals negative 30. Divide by minus 1, and I get y equals 30. So when x equals 7, y equals 30. And that is our second solution. Now if you look back on the graph on GeoGebra, you should see that our 2 intersection points were 3, 10 and 7, 30.